Hello, everyone, and welcome to our today's webinar. We are really excited about launching the new self-driving car research studio. And today you will learn more about this solution and how it can help you in your research. My name is Zuzana Fabusheva, and I'm here with my colleagues, Paul Karam, Director of Engineering, Derek White, R&D Manager, and Pasha Javid, Business Development Manager, to walk you through our new solution.
Thank you, Susanna, and thank you to all of you for taking the time out of your busy schedules to join us for this exciting launch that we're going to be talking about today. At Quanser, as many of you know, we've been in the academic business for over 30 years, and we're always looking for new ways to meet the challenges and demands that you as academics, both in teaching and research, are facing. What we're talking about today is the new self-driving car research studio, and this comes 2 years after our first true venture into the whole research studio space, where we launched autonomous vehicles research studio. And so on that success, we wanted to turn our attention and in discussions with all our customers for over the years, this area of self-driving cars and really autonomy in general, including things like artificial intelligence and machine learning, is obviously a big emerging trend that we wanted to get involved in, and knowing full well that also all our customers are interested in and going down the path. So we turned our attention for the last couple of years in really putting together a full-featured, very immersive and deep self-driving car research studio. So without further ado, I'll pass it over to my colleague Pasha, who will talk a little bit more in detail about what you can expect in one of these studios. And we're here to talk with you after. And so please send your questions to us, and we'll be more than happy to have the questions answered at the end of the presentation. Thank you once again, and enjoy the presentation.
Thank you very much, Paul and Susanna. Hello, everybody. Good day or good afternoon to you, depending on where you're joining us from. Thank you very much for being here. First, I'd like to start by saying that all of us here at Quanser hope that all of you, your families, and your friends are doing great and are keeping healthy and safe these days. We certainly appreciate the chance to have a few minutes to get connected to the community, and for the first time, I believe, speak publicly to a mass audience about the Q car and the self-driving car research studio. So we certainly have been looking forward to this. As mentioned by my colleagues, I'm not alone on this panel. I'm joined by Susanna, Derek, and Paul. And Derek and Paul specifically have been at this for more than 18 months. From pure idea and concept to the time that it was released, literally less than 30 days ago. It was an 18-month journey, a very interesting one that, as Paul mentioned, was based on our past success with drones and aerial systems. And it first started by answering a fairly easy question of why even self-driving cars. But as I say, it's not very challenging to answer this question, because even back then when we started thinking about this, autonomy and autonomous cars were already becoming part of our daily lives. Even back then, we had Tesla vehicles that came out of the factory with autopilot features and some autonomy already enabled. Since then, we saw other companies such as Uber and Google investing heavily in their own self-driving technologies. And while these technologies, like any other technology, provide a lot of benefits, they also create some problems, and there's always a learning curve. So to come up with an answer to the question of, do we need to pay attention to the education and research of autonomous and self-driving cars? Of course, yes, that's an easy one. The answer is yes. For us, the more challenging question to answer was to go out there, look at what was already out there, and see where we could help and add a value. Because even back then, a huge portion of the community was relying on what was out there already, such as the far left of the spectrum, where a huge portion of the community was relying on off-the-shelf kits for robotics, for aerial robotics, for ground robotics that have existed for several years. And they're great, and there is a huge market out there for them. And also some portions of the community prefer to rely on do-it-yourself solutions, some of which are very nice and are developed in-house, completely relying on in-house resources and expertise. And you also, on the other end of the spectrum, have actual full-sized autonomous cars that are, of course, very nice and are the real deal and the real thing. But when you look at those, you immediately, first of all, notice that the far left is obviously not able to provide all the necessities for a successful research platform. There is usually limited real-time processing ability that you would need on the actual vehicle for full autonomy, as well as software support and a lot of other problems. And when you look at the full-scale cars, obviously, as full-scale as there are, they're not scalable, department-wide. You cannot have a huge amount of these, a huge fleet of these. They're used exclusively for research by an exclusive closed group of people on campus. Not every student on campus usually gets their hands on such platforms. And of course, as you can imagine, these are high maintenance, while you get a limited amount of hours that you can actually perform research with these. And what you have on the far left usually costs in the range of a few hundred to a few $1,000s. And what you have on the right could cost from tens of thousands of dollars to a couple of $100,000s. So we looked at all of that and we said, okay, great. Do we want to compete with any of these, or is there a hole or a gap that we can fill, or do we have any value added? So what we decided to do was to kind of take it to the next level and come up with an entire studio or an ecosystem that would not only be able to address the problems that we defined on the left and on the right, but also act as a student-proof and academically appropriate platform for teaching and research when it comes to self-driving cars. So that's how this whole thing started. And of course, at the end of the day, we came up with what we think is the only validated platform that can be used to accelerate, expand, and sustain research in self-driving technologies. And what we mean by that is that if you look at the research groups out there, there is new research groups that are just starting, and they need to start producing results in a very short amount of time. So what this studio is designed to help these groups with is the ability to jumpstart autonomous car research programs in a very short amount of time and establish new research capacity in AI, in machine learning, and all of the sub-related areas that come under these umbrellas, as well as having access to an academically appropriate solution that allows the research team to go from idea to full implementation under a single umbrella and using a single platform. And at the end of the day, what this means, bottom line, for the research group is that they can start producing results in a very short amount of time that otherwise they would have spent creating or maintaining or troubleshooting a platform, and they can go literally from installation to publication in months. But you also have a whole bunch of existing research groups out there that have a whole bunch of platforms. Anything from what we saw earlier on the far left or on the far right could be out there already. So how can we help those existing research groups? Well, they can obviously, this can help them to expand their research portfolio in terms of hardware and software. So not only they can grow the collection and the variety of the vehicles that they use in their labs, but they can also, in a very short amount of time, add support for the languages that they weren't using, but they were hoping that would be available for the cross integration between their vehicles. So at both software and hardware level, this is an expansion for existing research groups, as well as it helps them to get rid of the dirty work that they're definitely familiar with because they've done it, but this helps them to get rid of it, which is the work of cross compatibility and integration between multiple development environments. And again, what this means, bottom line, for existing research groups is that it will create a major shift in their group efforts and their group behavior. And it will create a massive wave moving away from maintenance and housekeeping to doing actual research and validation and producing results. So what is it? Let's start looking at it. Actually, the center piece, or the star of the show, the star of this studio, is obviously the car itself, the Q car. It's a 1/10 scale model of a car. completely open architecture, as I'll try to explain in the rest of the presentation, both in terms of hardware and software. And as I said, most important is that it's an academically, or the only academically appropriate and student-proof platform for education and research. So of course, it's sensor rich. It has pretty much all the sensors that you would expect to see on an autonomous car. These are just a few. Of course, you would expect to have a 9-axis IMU sonar, encoders, digital tachometers, and the list goes on. And we can definitely share specifications. This is just a segment of the specs just to get the conversation going here and start looking at some applications. But again, just like you would expect on an autonomous car, there is a LiDAR, there is an RGB camera with depth measurement, and for the brain and for the processing, we are using the NVIDIA TX2 processor, which is itself a very powerful computer that is put on wheels here. So in addition to that front-facing camera that we just saw, we are also very proud and taking advantage of 4 160-degree view, 160-degree cameras installed around the car to provide, at the end of the day, a 360-degree view. And what we've done, which I might ask my colleague Derek to comment on at the end of the presentation a little bit, is that we've taken advantage of the GPU capability on the NVIDIA for processing these camera images right there, instead of going through any other protocol or passing it on to a host station. We're doing it right there, which has huge advantages when it comes to research in safety, and research when the vehicle is basically processing a lot of data, moving very at high speeds, and needs to process a lot of data very fast to make fast decisions. So what you see is actually a demonstration of this on the right, which even if the quality of the video is not great over the webinar and over the web, this is the type of quality that these cameras provide right on there for right on the GPU for processing. In addition, we also have an LCD screen with custom text support. It also shows battery level and IP address by default, but that text can be customized. As you would expect, there is HDMI and USB ports to interface. And one nice thing that this creates and allows is that you can also develop right on the car by connecting a monitor and your keyboard and mouse directly to these ports. You can actually turn the car into a development environment. But of course, you also have the option of developing on the host station, which we'll talk about in a second. One of the most my favorite and one of the most interesting features of this car, which kind of allows us to position it at the middle of the table I showed earlier, is this expandability, both in terms of electronics as well as mechanically. So when it comes to electronics, there is an array, a whole bunch of available I/O in the form of SPI, I2C, general purpose I/O, encoders, digital tachometers, and also a whole bunch of, as we saw earlier, USB, HDMI ports. There is CAN bus support on this. And what that means is that the user has full control on the scalability of this, on customizing this with any type of third-party electronics that they would like to add to the car. And again, what this means, bottom line, for the user in the lab, is that it kind of positions the car as just not just a research platform, but something that students can also use for their custom projects, for their design projects, and maybe even for competitions. When it comes to mechanical expandability, we will provide a user customizable breadboard for mounting your own custom hardware, which again makes it appropriate for the purposes I just mentioned. And of course, as you would expect, there is programmable headlights, brake lights, turn signals, reverse lights, as well as microphones and speakers, all of which are accessible through software. So before moving on, one thing about this is that, just like we have done a lot of research on impact resistance on our drone and aerial vehicles, we try to bring that same expertise to the ground vehicle, because this is no different than the drone. It will be used for research. It will be used in unknown conditions. It will be running codes that are not validated yet. So it has to be impact resistance, because we are claiming that this is shifting focus from repairs and maintenance to research. So that's why we spent a whole bunch of our design time doing this, on crash testing this and going through several iterations of custom bumper design and bumper to chassis interface to make sure that not only the mechanical integrity of the car is maintained during a crash, but also electrically nothing breaks, no PCBs are displaced or broken, no cameras displaced or broken, and this video shows that we've achieved it pretty nicely. But as I said, it's not just a car. It's an entire studio consisting of many components, the first of which is the ground control station, which itself is a very high performance PC with RTX graphics card, and it will be pre-installed with supporting tools for the Q card development and coming turnkey with all the software necessary installed, such as our Cork software license, as well as a whole bunch of other software packages that we'll talk about in a second. We will provide 3 monitors for ease of development and ease of application monitoring and running, as well as a high performance router, wireless infrastructure. And when it comes to software, when you look at this community, MATLAB, Python, C, ROS are usually the preferred and the chosen development environments by the community. So not only we've made sure that we support these languages, we've also spent a lot of time making sure that cross compatibility and proper talking between these languages is also possible. And that's again very important because it takes the burden away from the researcher to make sure that compatibility of one software doesn't contradict with the requirements of yet another software. We've taken care of all that dirty work, and this allows the user to do parts of their development in ROS while they implement the rest of their development in another preferred language and get these to talk to each other very smoothly and with no effort. And that was just a high-level list. This is actually the list of all the software and APIs that will eventually come installed on the car. And as you can see, it's very, very detailed. You see a lot of familiar software probably on there. But again, what's important is the cross-compatibility of these, which is taken care of, and it allows you to choose your own software, basically. Choose your preferred software and don't worry about the dirty work behind the scenes. So when it comes to ROS, for example, which is one of the top preferred languages when it comes to these research applications, our car will come with pre-installed ROS packages. We are playing around with gazebo support, and we will provide a few out-of-the-box examples, such as a simultaneous localization and mapping one, as well as open code to allow the users to add their own functions. What you saw on the right was a video of the car actually mapping our own Toronto office by driving around and creating a map of our office, which if you actually compare it with an aerial shot of our office and the area that it mapped, it's not bad, it's pretty accurate. And it's a good out-of-the-box example, you know, to put in front of students and see what they come up with when they have such an infrastructure. But as we mentioned, Python and Simulink cannot be left alone. They're also highly preferred and highly used by the community. So when it comes to those languages, we will also provide a suite of examples, including low-level sensor interfacing, basic I/O interfacing to various sensors and I/O of the car, the interfacing to the CSI cameras that I mentioned, interfacing to the depth camera, the LiDAR, as well as collective data set logging and 360-degree imaging, which is kind of shown on the demo on the right, where the car is doing a couple of things. First of all, it's following the line on the floor. But second of all, the LiDAR is deployed and it's creating a real-time map of the surroundings. Moving on, more Python and Simulink examples involving autonomy with analytic image processing, such as recognizing a stop sign and reacting to it, as well as vehicle-to-vehicle cooperative adaptive cruise control, and in general, the necessary block sets to let you create multi-vehicle applications of any sort. So what you see on the bottom right, for example, is an example that the cars are following basically the road, but also avoiding obstacles as they come across them in real time. And you can extend this to include more vehicles or more obstacles. But moving away from Python and Simulink, Unreal Engine is also something that we've spent a lot of time with. And what this means is that this allows you to start from pure simulations, such as the ones that you see here, and have access to a rigged and animated Q car model, and have the ability to simulate LiDAR, depth cameras, and 360-degree videos, and create environments that are basically designed by yourself. And this means that you can create many, many different scenarios and exercises depending on what you're doing, whether you are challenging the students in the form of a competition, or you're actually validating your code for the first time in the form of a simulation. This is what you can start with. But things get interesting when you start to think about hardware and software integration in real time. So hardware in the loop simulations, basically, where your simulation is talking with the actual physical car in real time, and you can have either on vehicle or on PC image processing, and we will also provide road segments matched to the physical studio road surface of our solution. But again, as I said, the flexibility is there for the users to create their own scenes and their own scenarios in pure simulation, in conjunction with the real car, or with the real car on its own. We are all familiar, when it comes to any type of research with autonomous cars. We are all fairly familiar with the classic tape on the floor situation. We've all done it. We are all guilty of having done it. But to make this a maintainable and scalable platform that everybody can use and publish results on, we also thought about the environment and how can we scale and maintain that. So we will provide training sets that include very, very rugged and robust flooring that will extend to 43 meters or 140 feet of linear travel, and it will translate to 700 square feet or 65 meter squares of reconfigurable flooring. We will also provide signage for traffic scenarios and the various signs. But one thing that I should mention about this flooring is that it's honestly very rugged. We've had these lying around our office in various locations, anywhere from R&D to the warehouse, which sees heavy traffic, to see actually if they do tear up or not. And we've done heavy testing on them. And they're holding up very, very nice, and they're very modular. As you can see on the left, you can have anything from simple straight roads all the way up to complicated scenarios that are non-repeatable and modular. So for example, I apologize if the videos are a bit choppy on your end, but this is actually a very long road that we created around our own office. So for labs or lab spaces that are cluttered at the center, or the student spacing is at the center, and it's difficult to create a meaningful long enough road that you can do research on, this is how you can get away with it. The modularity of this flooring allows you to create very, very long linear roads. Or if your scenario is vice versa and you have a small kind of empty space, then the modularity of this allows you to create, kind of communities or built-in within roads inside that space. So this is it driving in our own office. It doesn't show very well in this video, but it is actually driving at 3 meters per second. Of course, it's also avoiding obstacles as it comes across them. And last but not least, before opening up the floor for your questions, I do want to give you a glimpse and a sneak peek of what we are working on now that it's been released. We are not done. Derek is certainly not done, and this is where our head is at these days. We are playing around with augmented reality using Unreal Engine, and what you see in this video is in the embedded portion of this video, you see the car, the actual physical car driving around in a I'm not sure if this is playing properly or not, but what you see on the bottom, on the top left, is the actual physical car driving around in an empty space, and the camera view is shown in the rest of the overlaid video. But what we've done is we've overlaid scenarios and objects, in this case a city basically, onto what the camera sees, and now the car in simulation can react to the actual physical car can react to what the camera sees in simulation as a result of the augmented reality added to it. So this is something that's a work in progress. We are playing around with it, but we will have something to share in the next couple of months. And we do truly believe that this will hugely affect the way not only research, but also teaching and student engagement is done when it comes to autonomous cars and self-driving vehicles. So with that, I will stop and I will hand it over to my colleagues to answer your questions. Please feel free to submit your questions. We have a great panel to answer them. And once again, thank you very much for being here and thanks for listening.
Thank you, Pasha. That was really informative, and we love seeing all the videos. I'm sure all of you do too. And if they didn't come across as nicely through the webinar, please reach out to us, and we will be sending you a link to the recorded webinar where you'll see the videos play the way they were captured. But we'll also be taking questions now, so feel free to send us all your questions. So I'll start with one question that came in, and I'll ask Derek to elaborate on it. So it seems you guys have put in a lot of effort in these CSI cameras. Can you maybe elaborate what exactly you've done there, and can I plug in my own cameras?
Thanks, Paul. This is Derek White, by the way. I've been the manager of this project for the last 18 months, and helping with many aspects to this, in particular, working with our electronics developer. The CSI cameras are the same sort of camera that you would find in a cell phone. They are they can be a very good image sensor, but they're a little bit different from what you'd find in a web camera. Usually the webcams are going to be something you can plug in through USB. The amount of information you send over USB, there's a lot of overhead associated with processing the USB channel. Once you do get the images into the car, then you can process them as normal, but it would be no different than, say, reading a file or streaming something from over the network. With the CSI cameras, they are unique in that they're very closely coupled with the hardware. So they have a direct path, basically going from the image sensor directly into the GPU, where we do some initial processing on them, and then they're immediately available to the user at that point. So it's something that really unfortunately didn't come across well in our webinar videos there, but you can get up to 120 frames per second. So that makes a big difference, particularly when you're driving at 3 meters a second and being able to react to obstacles. That frame rate is going to have a big impact on that. Most web cameras, you're going to get 30 frames per second, and that's also going to result in a lot of image blur. So you'll have that will make image processing more difficult. And once you have 4 of them, that's a tremendous amount of CPU overhead just to manage receiving the cameras, whereas the CSI cameras allow you to just get it directly into the GPU with virtually no overhead to the onboard CPU.
Thank you, Derek. Another question that just came through this time, I'll ask Pasha to comment. How can this platform be used for developing teaching courses?
So that's a very, very interesting question. Obviously, right now, we are calling it a research studio, but having spoken to many, many people in the community, we do understand that there is a big appetite out there to use this as a teaching platform. So another thing that Derek's team are working on and will have something to come back to us with in a few months is actually teaching curriculum and teaching material, just like the other teaching material that our users have come to expect from Quanser with our other solutions and equipment. So that's something that's in the works. We will come out with modules that will have topics that are appropriate for courses such as estimation and control of unmanned vehicles, cyber vehicles, etc. But one thing that we are also looking forward during this process is feedback from the community itself. To let us know what are the appropriate topics to be taught in an undergrad course when it comes to self-driving cars. We are certainly open to that feedback. We would appreciate it, but we are thinking of that, and certainly in the next few months you will hear more from us about specifically the teaching aspect of this and the supporting curriculum material.
Okay, so thank you again. These are great questions. So there's a few questions here that I'm sort of going to put together and ask Derek to comment on. So they really, I think there's a lot of interest in the fact that we are very software agnostic and interoperable in our approach to various software environments. One of the questions that came up, the ROS support you mentioned is for ROS 1. Do you have plans to support ROS 2? And an extension of that is how about combining ROS and MATLAB at the same time? Is that possible? And what environment would I need? So maybe Derek, you want to maybe elaborate with what we've done on the software aspects of the solution?
Sure. Let me start on the ROS side. So we have, if for people who have used our products in the past, and predominantly our work has been built around MATLAB Simulink in the past. It was a key part of this project that we were going to start introducing additional languages that we directly support. We have always supported the HIL interface, hardware interface through C, C++, and as part of this, behind Quark, this MATLAB Simulink, there's a lot of underlying libraries that generally aren't publicly available. We've increased those libraries to expand those to communications and essentially all of our media stuff, all the cameras and a number of the devices, the LiDAR, all these things to basically make this car fully accessible through the C API. So from there, we built our Python API on top of that. And predominantly when you are using ROS now, ROS can be built on either C or Python. We have made a number of ROS 2 devices where they're all built on the Python API. And you have, from that you can, because the source for the ROS packages are open, you can change what is in there in order to optimize things. We have done what we thought is the most optimal methods for getting data across the network, but you can certainly change it from there. The mapping example that you saw is the actual map was generated using a ROS 1 package while the car is running a ROS 2. There's a bridge that is available from ROS 2 to ROS 1, and all that was running on board, the ROS 2 was all running on board the car. The mapping was running on our on Windows using Linux or Windows. However, if you prefer, you can also be running in a pure Linux environment as well. In terms of MATLAB interoperability, so one of the things that we have really tried to build with this is that it's not just, you're not just purchasing a car with one language in it. We're supporting all the languages on this car simultaneously. And as Pasha had alluded to, you don't need to just be working in a single language. You can do, for instance, you could do the control of the speed control and the steering in MATLAB Simulink. You could be doing the AI in Python. You could be doing the image processing in C, and all the different subcomponents could all be talking together at the same time. This can help facilitate, you can bring in someone into your lab with the expertise to do some particular thing, but they aren't tied to a single language in order to work with other members of your lab. So the interoperability, the multiple languages really makes this particularly powerful. And this is something where we've spent a lot of time getting all these pieces to work together, because often with these different packages, they are very particular about what versions things need to be. And so making all this stuff work together at the same time is where a lot of our effort went into the software experience.
All right, thank you, Derek, and thanks again to everyone. I'm just watching the questions just raining in here, so keep them coming. These are great. I'm going to do my best to sort of summarize common themes to put it back out to the panel. So here's one maybe for Pasha to tackle. The Quanser Q car and the entire studio look very interesting and capable, but can you tell us about the expected price range? Is only one Q car included? Thank you.
Thank you for the question. We'll be happy to provide you with that information. No, it's completely modular. To give you a short answer, there's no limit on the number of vehicles. We have several packages that we offer it at with 1, 3, 6, or more vehicles, but it's certainly up to the user to choose the number of vehicles based on the space that they have available in their labs. When it comes to pricing, we do have distributors in some regions and we do go direct in others. So based on your region, we would be happy to either direct you to the right distributor or to the right contact within our sales team. So we'll be happy to have that conversation even as soon as after this webinar. If you contact us or submit a code request, you'll immediately hear back from us.
Thank you, Pasha. And there was another question. So an extension to that, is the studio on the Q car available now? And I'll answer. I'll take that one. That's an easy one. Yes, it is. And we're very proud to announce that we are accepting all interest right now, and we're ramping up our production of the whole studio as well. There is maybe over to you, Derek. Couple of questions in terms of the mathematics and dynamics and kinematics, so the various mathematical equations of the Q car, and how do we plan on continued support of the software? Is it going to be a repository or a growing library, and how do we expect people to interact with that?
So that's actually a really interesting question. We have a couple different things that we're looking at. So some pieces of this are probably going to be on GitHub. However, the nature of GitHub is that it's really something that's oriented towards code. If you purchase the whole studio solution, part of that solution is, in addition to the cars that come with it, there's the PC, the road surfacing, signage, all this working together. On that PC, we have pre-installed the Unreal Engine, and with that comes all the essentially a bunch of examples and templates and things to help you get going. Creating these simulations, interacting simulations with hardware, it can be challenging. We'll have some that are pre-compiled to more or less get you going right out of the box, but I'm sure that very quickly you want to move on to custom stuff. Unfortunately, because Unreal is, and all the graphics and whatnot are really large, that doesn't play very well with GitHub, particularly with source control. So we'll probably, I believe, some of this other stuff we'll probably be doing through other distribution methods. Probably through our website or direct links. We actually haven't quite figured that out right now. We're still, because right now essentially is going to be, at this point, we have a current software package. Our plans, we're going to do continued software updates. Our next major update is going to be planned for June. So some of the stuff that we were showing you in terms of the augmented reality, that will be part of our June release. It is possible to do right now, but in terms of actually more complete examples, that will be in our June release. And then we'll certainly be trying to continue to do this on an ongoing basis. Something that I would certainly like to encourage people to do is, if you have questions about models, please ask us, because you may not be the only person that has that question, or you're looking for an example of how to do a particular thing, and we can try to get more out there. In terms of the framework of examples that we are providing, I guess if anyone who has experience with our aerial solution, we had just a couple very large examples, and part of that was the nature of the complexity of flying a drone. We've taken a new approach to this to break this down into a lot of smaller examples that build up to more complex examples. And because there's such a huge span of potential research areas, the idea being that you can use one of these possible starting points and then build on it from there to get closer to your research. So out of the box, it can follow lanes, it can do adaptive cruise control. We're trying to start you at a high level so that way you can get right to where your research is, and help push your research to the next level. Did I get everything?
I think so. There's a few questions that I can just field, and then I'll pass this over to Derek again. Couple of questions. Is there a university already using the vehicle? Yes. So we have worked with some of our some lead users, some alpha users. We also have our first customer at the Royal Military Institute of Technology in Australia as well. And we've been working quite a lot with them in the past with various other Quanser products, and they have a lab of 6 vehicles here. So that's just to give you an idea of some of the scale. There's also a lot of questions around Carla, and we have been looking at the carla.org, infrastructure, and we want to see ways for us to leverage that organization and that technology as well. And then maybe I'll address one last one. I'll pass over some other more deeper questions to Derek as well. This question was, does the system also provide first-person view and thus manual control? So the easy answer is yes. The longer answer is really with any Quanser product, especially our research targeted studios, they are completely open architecture. And what we mean by that is anything is possible. So we do provide a wireless joystick with this studio, mainly for just another user interface. But we will have an example where that joystick can be controlling the car in a manual mode, so there's no to little autonomy, and you can see the video feed being sent directly to your console, so you can see it and drive in a first person view. But the longer answer to that is anything you want to implement, be it any type of cooperation, any type of control, any type of communication with vehicles, V2V or V2I type configurations are all possible. And so like we try to do, especially for our research studios, is really give you unlimited capabilities, because we know everyone's research goes in different directions, as it should. And so we want to make sure we've given you as much flexibility as possible to meet any research needs as well. A question for Derek. Could you elaborate on the battery lifetime when you're driving or testing the car, and maybe elaborate on some of the biggest challenges of while testing the solution as well?
Sure. Yeah, and I was scanning through a few of these other questions as well. So in some of our earliest testing, if you were just running the car at a max speed and you're basically just driving it by remote control, you can get about 1 hour of battery life out of it. If you are doing max speed, every camera, every sensor, streaming full video all the time, you get about 35 minutes out of a battery. Now, if you're doing on-car development, or you're doing something that doesn't require the car to actually be driving around, the package also includes a power supply, so you can just plug it into the wall, and then that way there's no limits. So that's great when you're still just doing development. And then the obviously where each car includes 2 batteries, so you should be able to cycle through your batteries pretty much continuously then. There's another question. Someone was asking about using a global navigation system, so like GPS, something like that. This is predominantly designed for indoor labs, so of course you're not really going to get much GPS inside. However, we have tested this with external tracking systems, so you could use something like OptiTrack or Vicon cameras, and we've put markers on here, and you can track them in an environment, mixed with other things. So it is certainly possible to do that. Quark does have built-in support for both Vicon and OptiTrack. For those that aren't familiar with Quark, Quark is a plugin for MATLAB Simulink that we use for so when you use MATLAB Simulink, it is generally a block diagram, graphical interface. From there, you can generate C code. What Quark is enabling is it adds additional functionality to that block set, and we're also providing the cross compilers and the automatic downloading of your code. So you build it on your Windows machine, and when you run that, it will automatically download your code to the car, and in real time, it will stream your video, your plots back to the PC, and you can change parameters on the fly. So we certainly use Quark a lot for real-time prototyping, but there are some things like doing AI training, which are much more easily done in Python, and hence why we're trying to support a number of different languages. And another one was LabVIEW support. At this time, we are not supporting LabVIEW on the car. There are code generation options with LabVIEW, but we have not experimented with those at this time. Generally, LabVIEW is for pieces of hardware that are also built by National Instruments, and as such, we don't. It's not something that's currently supported.
All right. So Derek, a few questions around the NVIDIA platform and sort of why we chose NVIDIA as our processor technology for this studio. Maybe you want to elaborate on what we're doing with the NVIDIA TX2 and what's capable, where those capabilities are as part of our choice to have it be our processor.
Sure. The main reason for the NVIDIA was really they have a scaling of platforms that ranges anywhere from one of the earlier TX1s right up to their Xavier systems that are extremely high end. The TX2 is actually being used in some full-scale vehicles. So part of the thinking here, and a big part of that is its GPU capability and what that means in terms of its ability to do both image processing and for training and for execution of neural nets, is that we can develop things on here, be it the image processing, the algorithms, and get a realistic idea of how long it can take it to execute. And you can take those exact same algorithms and then apply it on a full-scale vehicle as well. So, if you're a lab that already has full-scale vehicles, then we see this as something that can be a complement to your systems, because in one case, it allows you to test things in a environment that is a lot safer, and if you crash into a wall, it's not a big deal, and you can try to proof out some of these systems before you apply them on a full-scale vehicle, and sort of having that path of progression, saying, if I need more processing power, then on my full-scale vehicle, then there is a progression of hardware options that you could pursue as you go down your research path.
Okay. Some other questions that come in here as well. So do you provide sensor models for the Intel RealSense camera and the Unreal Engine? And some people are asking about some more control techniques that are possible. I think, and then there's one more, maybe I'll hand that one off to Derek as well, but maybe on those two, yes, we will be providing sort of the sensor modeling capabilities within our virtual environment, so that you do get, when the car is in the virtual world, it is interacting with that environment and giving you, through the same sensor feed, what you would be typically getting as if that environment was in the real world. And so we've implemented that as well. And as far as different control algorithm techniques, again, really, because it is an open architecture system, it's really up to you to implement. To give you a simple idea, what we've done with some of our developments to date is we have a speed controller that regulates the speed of the car as it travels around the track, and it's using the front-facing CSI camera to detect the lanes and keep the cars on the lanes. Over and above that, we've also we modulate that speed command and that speed setting based on some other sensors. So we are looking at the LiDAR to give us obstacle avoidance. We are looking at the RealSense depth information to detect obstacles, and then that also modulates it. So that's just one example of what we've done with the multi-vehicles, so that, if one is going slower than the other, then the one that comes in behind it will slow down. Even though you're telling it to go faster, it just won't. So that's kind of the adaptive speed control. But really, these are just examples of capabilities, and any control or guidance and navigation, organization or implementation you want to try, is completely possible. And we want to be working on these libraries of more and more examples of exactly just that. So maybe over to Derek, do you offer the simulation purely as a virtual product or only in combination with the hardware? Actually, maybe I'll throw that over to Pasha, please.
I believe it will come in combination with the hardware as a sub part of the entire studio. Derek can correct me if I'm wrong, but at the moment we don't have any plans of releasing just the virtual model as a separate and standalone product.
That's right. Yes.
Yeah, there may be at some point we may have an example of what it may look like, but really you won't until you have access to the full thing. You won't really be able to leverage it to tune it to your research, because each simulation is obviously to do something specific. So you want to have access to the full Unreal Engine, so that way you can customize it to be whatever you want. One other question I saw that came through here was someone was asking if you could emulate other types of vehicles, off-road or truck or SUV. This is built on the Traxxas chassis, and this thing is highly configurable. You can take apart everything on the mechanical chassis there. You can change the wheels. If you were to say, maybe you wanted to add $100,000 lighter on top of this, but it's really heavy, you can change the spring compressions and the suspension there. You can change the fluids to get a different damping ratio. So we're obviously only shipping this in one configuration, but you certainly have the ability to wildly customize this any way you need.
Another question, maybe I'll take it on before I pass on another one to Pasha, is what's your solution for anti-collision system? That's a great question. So again, because it's completely open, you can choose any of our sensor suites to synthesize and fuse the different sensors for you to make decisions on collisions and collision avoidance. What we've typically done is use both a combination of the LiDAR and the Intel RealSense depth information to give us that collision or obstacles identification, and then we do something with that information. For example, slow the car down or tell it to come to a stop until that obstacle has moved out of its viewpoint or out of the trajectory that it was on. Another question that keeps coming up, and maybe this is, for more information on this, please contact, your Quanser contact. But in terms of Quark and how does that, what is Quark and how is it linking MATLAB Simulink to the car? So just at a very high level, Quark is Quanser's software, and what that, at a very high level does, it allows you to take a MATLAB Simulink model and generate real-time C code from it and compile it into an executable and run it on whatever target you have. So in this case, we use Quark to work on the ground control station. It's a high-end PC, so you have all of MATLAB Simulink and all the power with MATLAB Simulink. You build your algorithm in Simulink, and then you deploy that over to the car. And the benefits of something like that, and that's why we've always been using Quark in this fashion, is while the car is driving, you still have all those signals available to you in Simulink as it's driving around. So you can see all your algorithms and what's happening and in real time while the car is navigating whatever experiment or whatever algorithm you've implemented on it, and see it in real time. So that's really where Quark and Simulink come into place. A question for Pasha, maybe you can elaborate. If a customer is interested in the Q car but has a limited budget, do you have any minimal base offerings of the studio? In other words, what are the optimized elements that we can play with in order to drop the price in order to, when ordering the studio, for example, the ground station PC and things like that? Is that really necessary?
All right, yeah, thank you for the question. That's always a conversation that we're open to having. The short answer is yes, but the debate is always goes back to every element that you shave off the studio, it's basically taken away from the claim that I made at one of my earlier slides, that it's an academically already integrated platform. So basically every element that is kind of taken away from the studio, it's more work imposed on the user to get it back to the same state that it would have been, and it kind of takes away from the user experience. Is it possible? Yes. So there is a minimal offering. You can even just get the car on its own without anything else. But as I said, that means that you are accepting responsibility for not a little, but actually a lot of significant software integration and making sure that the right specifications on the PC and everything else is in place. So we are certainly open to having the conversation, but what we would probably suggest, if it's a budget is limited, let's get on each other's, let's team up and let's go out and look for funding for you that would allow you to get the full studio, because that's really what we are what would add value to the research. I hope I can I hope that I responded to this, but if you are in that situation, please feel free to reach out to your local distributor or to your Quanser rep, and we're more than happy to get engaged in that conversation.
There was a question about GPS tracking again, and this is the global navigation. As I said, GPS is science intent for outdoors. There is a huge amount of I/O that is available on this. Serial ports, Ethernet, SPI, I2C, GPIO. If you want to use this with GPS, you can certainly plug in a GPS module to it and it will work.
Hello. One other question about, do we have experience in the EU market? And definitely we've been, like I mentioned earlier, we've been in the academic market for over 30 years. That is the only market that Quanser operates in. And we have many great partners that, work with us and represent us in various, European countries. So please, again, just reach out to us and we'll put you in contact with the right people that can demonstrate our capabilities and have that discussion with you in your local country as well. Okay, so I believe we hope we've answered all of your questions up to this point, and they were fantastic questions. Again, thank you for everyone for participating, for taking time off your definitely busy schedule these days to make time for us, and we hope this is just the beginning of our conversations around the self-driving car research studio and other possible offerings that Quanser can help you with. Please feel free to reach out. Please feel free to subscribe to our newsletter as well. And thank you once again. And I will hand over to Susanna.
Thank you. So thanks again, everyone, and stay safe and healthy in your part of the world. And hopefully we will be able to meet you also in person very soon. Thank you.